Today I'll look at the Xeon D-1518 4-core system on the left and the Xeon D-1528 6-core system on the right. Just give you a clearer picture of what we got going on here. The machine on the left has 4 cores. It's actually bigger with more network interfaces. Ignore this PCI slot, by the way. That marketing picture is wrong. There's no PCI card included with the system. But worry not, you have SFP. You actually have 9 Ethernet interfaces. Okay, so let's move along. Here's a look at IPMI in that system. Firmware version 3.26 and BIOS 1.1. Okay, now here we have a newer firmware that actually has this new feature. All right, so I just want to point that out. But today I want to keep the systems as similar as possible to yesterday's demo, where I took you through these systems. Mini tower. Okay, so the mini tower, I looked at the fans, I looked at some differences in these two systems. And again, let's see, that's an 8-core on the left and a 12-core on the right. Today we're looking at a 4 and a 6-core. So we want to get an idea of scaling. How scalable are these systems? So that also means I should go ahead and do the same tests as yesterday. Let's start with a look at temperature before I start abusing things. All right. Here's our temperature. It looks like I've got maybe an IPMI problem or something, but I've got to return this system in just a few days. And I have a flight tomorrow for a demo, so of the machine on the right. So I'm not so worried about the machine on the left at the moment. But anyhow, let me move along. It is a little weird that we're missing some stuff there. And that could just be the rawness of that BIOS 1.0a. It's a new system and a different motherboard that's a little wider than the one on the right. All right, what are the relevant things for looking at temperature? Well, if we go to configuration and fan mode, that'd be a good place to start. So I'm going to stick with what I did yesterday, and that is standard speed fans. All right, so we're good to go there. And the BIOS is at the same settings as all the demo stuff I did yesterday as well. And here's some of the basic stats, by the way, in these machines. E300, E200. 4-core into my mouse pointer there and 6-core here. Again, covering the 8 and the 12-core yesterday. All right, so it's time to dig in and get started finally with the actual tests. So here we go. I've already shown you this. Now what happens if I start Prime 95? Looks like I still managed to not pin that folder. Sorry about that, but that's okay. There we go, Prime 95 getting launched over there. And let me get it launched over here too. Literally, I moved the hard drive from the old systems to the new. So the same stuff I did yesterday with the same exact operating systems here. So yes, the build is very much the same. Okay, you've got a lot of windows going here. It's getting a little confusing, but I'm ready to watch Task Manager as I get this workload underway. All right, so we've got the CPU showing 4 and 4 times 3 are 12. And I'm ready to roll with the default Prime 95 test. And to get that running, I guess I'm going to be doing that and then minimizing this. You saw the threads launch. Same deal here. Run it. Threads launch. Minimize. Don't really need that window anymore. So I can hit Alt F4 there to get rid of the Explorer window. So now we should have similar number of threads on the two machines. So they're pretty close, not identical. And temperature showing in real time in the background there. That'd be good if I had the same screen. So we can also see that there's only one fan. These are passively cooled as far as the heatsink, and one is a taller heatsink than the other to let hard drives clear or not. So I'll just point that out. The innards of the system, they differ as far as the cooling solution for the CPU, with a taller heatsink for when you have 6 cores versus 4. All right, so we're not seeing a whole lot happen there. The temperature, the CPU is obviously cranked to the top. How are we doing on temperature? CPU temperature. Okay, 56 on the left, 66 on the right. So this this is the gist of what I did yesterday. I let it run for quite a while. I wanted to see how it goes. Today, I don't have as much time. I'm not going to run through the whole sequence of leaving this running for a very long time. But we probably could get a pretty good sense right away of how the temperature of components do, including the DIMMs. Okay, I'm going to need to get rid of this display for a second so you can see. Probably should. There we go. So you can see that all the DIMMs are now showing. So now the two machines show something similar. All right, it does bother me a bit that we're having this issue with IPMI. It's kind of strange. So how about I do a unit reset to reboot the IPMI device. And let's see if we get some of the red out. So maybe I've found a flaw in the BIOS, maybe not, but either way, rebooting IPMI is also going to take out IKVM. So I suspect we're going to lose our display momentarily here on the machine on the left, and maybe we'll come back with some of the red out. Okay, connection disconnected. It closes, and then we get this UI taking a little while. Meanwhile, the machine is still under test, so we're still getting some stress to the system going. On the right, we've got up to 72 CPU temp. That's what happened actually on the 12-core system after a few minutes. So it seems that might be the design point of these systems with an ambient room temp of about 70 Fahrenheit. So 72 Celsius is what we're reaching, or 161 Fahrenheit. Not a big deal when you go all the way to 96 and thermal shutdown. Still doesn't happen on these CPUs, or 95, somewhere around there. All right, so on the left, we're going to need to log back into IPMI once it starts responding, but it is not there yet. On the right, just to double check, if you look at Task Manager, yes, you see it is taxing all the CPU cores. And the gigahertz is lower. So when we have this comparison chart, it's really useful because it talks about gigahertz as well on the various machines. So you'll see the E200, 1.9. And the E300 on the left, well, that's supposed to be around 2.2 for the gigahertz. So we'll see if that's true shortly here as I get back in. So IPMI is back. We're about to find out together if things are behaving a little better as far as the display there under Windows Server 2016. GA code, by the way. It's no longer beta, which is good. Notice it still shows red here, by the way. You can always click refresh preview. And it looks like it made no difference. So maybe I've revealed an issue with this version of the software for monitoring. It might not be compatible with this motherboard. So that might be completely on me running SuperDoctor 5. Not sure if it's intended to run on this different motherboard. It's a different Xeon D, remember. That is SFP 10 gig instead of RJ45. Okay, so let's ignore the red, because I've tried to convince you we really shouldn't worry about it. Different animal probably needs a different version of software. I don't really know that. It's just a theory. Maybe it's a long shot. But that'll need more research. Okay, so the point of this video, there we go, clear video, is to see that the two systems under load for a long time reach a steady state and the temperature of the various components no longer continues to climb. I think I've reached that. We made it to 73 briefly there and went back to 72. All right. Now, to gather as much data as I can, how about I do fan mode? I can always go back and analyze this later. People ask me questions about this stuff and get an idea of what can be done here. Okay, so now we got the fan mode on maximum. Okay, and what did that do? We can do sensor readings here and see the stuff, and there's nothing red there. So that should convince you that SuperDoctor's having an issue, but there's nothing wrong with the system itself. The unfortunate thing here, though, is you kind of have to hit refresh. On the older IPMI, like this, Or in the new one, you click auto refresh and it should display. Look at that fan, 13,000 RPMs and 12,000. So of course they're making quite a bit of noise in the home lab. Not ideal. I'll be the first to admit that, and you can see the fan is looking pretty busy over there. It's gone to 11. No, just kidding. It didn't go past the top, but it hit the top, the needle. Okay. But you'll also notice the temperature start to come down. So yeah, if you're running in a data center, don't care too much what it sounds like. Do these numbers worry me? Nah, not really. These systems even run with the motherboard off. The chassis shell or cover off, and it's really not that big a deal for too long, but you wouldn't want to exercise it this heavily, because when they're one you really do need that proper airflow and the lid on for the air to be drawn from the front to the back. Okay, I'm done with that. I'm done running Prime. Okay, now in a normal home office, home lab situation, you're going to go back to normal fan mode. I am experimenting with different fans, by the way. Don't have a lot of time left to do such experiments, but I'm just letting you know. I don't think I'm going to find any miracle in that it was very difficult in the mini tower to find a fan that cooled as well as the stock factory fans. Okay, so now we're back to standard speed on the fans. Ready to head back here and do something else besides just looking at a web browser view of the temperatures. I'm going to run Camtasia just like I did yesterday. Okay, and I'll resume this video once I've set up that render job, and we'll time it and see how long it takes to render. So yesterday, I think it was it 22 and 34 minutes, something like that. Pretty much one being 2/3 of the speed of the other. Should be similar today because we have 4 cores versus 6 cores. Versus yesterday's demo of 8 cores versus 12. So it'll be interesting to see if we get kind of linear scaling on a compute-heavy task like this. So it looks like I'm ready to just start them both off. And I'm starting them both off at, this is a 4K video by the way, very intense. Almost 12 minutes long. Okay, looks like we're starting them both off at 11:06. And off they go. You want to be convinced, if you haven't seen that other video, that they're using all the CPU cores for this, that Camtasia uses all the CPU cores for this. Well, hopefully now you're more convinced. Let's let that run a little longer and move this over to the side. Right, just going to let it run a little longer. I'm going to let it complete. All right, so now I'm ready to bring up Task Manager again without obscuring your view of the progress bar. All right, so that's it. Gonna let her rip, leave it alone. I'll bring the video back when I've got some progress to show you, ideally at the end of the first one and at the end of the second one, so I can kind of mark it on a stopwatch and see how long each of these very intense render jobs actually end up taking these two systems. Notice we have higher gigahertz here, and this one has lower, so that confounds the results a little bit. It seems like they kind of, derated this processor a bit, making the well, the gigahertz is lower, probably for temperature reasons and whatnot. They can tune it. I do not have a theory on why I'm only getting 79% utilization. This is the only CPU we've seen do this. So I'm not getting 100 out of the machine on the left. Is it because of some sort of thermal issue? I doubt it. But just in case, how about I go to sensor readings here and see what's going on? Anything exciting happening? Not at all. If I crank up fan mode, does it decide to kind of let me go further? Does it change anything about this Camtasia render job? Seriously doubt it. Nope. Okay, did that change anything? Not at all. So, just going to let it go. I don't like a mystery. I want to understand what's going on, and I don't currently understand why on earth it would run differently on that machine. Other than it is a completely different motherboard. It's not the same design. Actually has 2 PCI slots, as I mentioned earlier. Why it would behave differently under workload like this, I couldn't tell you. It's probably meant more for like firewall market and a whole lot of network interfaces. You can see a whole lot of Ethernet interfaces, right? But yeah, again, don't have a great theory. I will point out I didn't hook up all the Ethernet interfaces. I don't have enough ports on the switch I'm using is one problem, but also the difference or the delta in power use goes up very little unless I'm using really long cables, like 100 foot or something, or maybe even 100 meter. Even then, I think when I did it is like less than a watt, well under a watt per port. So it really doesn't change much if I hook up those ports. Speaking of watts, that is the one thing I totally forgot to show you during this whole video. So let's fire up CyberPower's look at watt burn as this video render job continues to run. And here it is. Okay, so now you get an idea of, hey, what's it cost, or what's the compute power per watt burned of my valuable dollar, my electricity to leave this stuff on in my home, ideally in a home lab. And you can see it's a pretty modest 54 watts or 66 watts under full tilt. Okay, and then here we are going to be at 5% on the left, 8.9 on the right. So yeah, it looks like the machine on the right not only is it going to win, but it's going to win by quite a bit more than I expected, actually. So all right, and actually if I leave that down here, we should be able to see that even while the render job is still underway, and even while I leave Task Manager visible. Darn. Let's do this. Okay, 66 watts. There we go. All right, finally, I'm done fiddling with the mouse and all this talking. I think I'm ready to let it finish now. So we'll see in a little bit when I've got something to report here as far as progress on the render job. And be right back. For now, I'm just going to pause the recording of the video until the render job on the right finishes, and then I'll resume, and then fast forward again in time to when the second machine finishes. So again, we start at 9:06 p.m. Pausing now. Okay, looks like it's time to do a little more math. We are just about to finish at 9:51 from 9:06 with the first video render job. It just did 100%, then you're going to see Camtasia open up when it's done. You may wonder, why would I do a video rendering job in a server? Well, whether it's GPU or software only, I haven't seen that much difference in the past. So if you have 10 gig or even 1 gig, moving a video job from a one SSD equipped like laptop to a very powerful server with a whole lot of cores could be pretty interesting, even if it's a virtual machine, if I give it many vCPUs. So yeah, there it is. It's done. Now pause again. Okay, it just finished up. And you'll see, I don't know if you saw 99.9 or 100, but it's about to pop up that Camtasia window when it actually is done rendering. And now the CPU is dropping off and the watts are dropping back down. Once Camtasia pops up with the final rendered video, the watts should drop down even further. So that took a while. I'll go ahead and make a table up and an article at some point just kind of summarizing what these results were for this same video render job on all of them. But I've now marked the spot 10:26. So started at 9:06. It's an hour and 20 minutes. The first one was, let's see, 46 minutes. Wow. Big difference between an hour and 20 and 46. But anyhow, that's probably about it. Whoa, it shows 0 watts briefly, but that was wrong. Okay, let's look at the gigahertz here. So they settle way down. That's, speed step in action. And why the watts are jumping around a little bit, not really sure. How about I close this, close all that stuff. Video playback. Not going to work on a server OS anyway. All right, so I should be back at idle here, and clearly some sort of signal cable issue going on there. Odd. Anyhow, yeah, a few less watts on the left than on the right. So now I've got some more data to add to my comparison table. And I'll need to, update the information here, particularly these last rows that get into power. So hopefully you found this video helpful. Thanks for watching. And thanks for visiting tinkertry.com.